The first significant part of this course is the technical design portion, where we're going to be walking through the design of simple devices. And to do that, we're going to talk about electronics, mechanical, and software approaches to design, and then how to integrate those into interdisciplinary devices. Before we start with any of those three disciplinary areas, a little bit of overview thoughts about device design in general. So to begin with, we're going to talk about devices as interdisciplinary products, interdisciplinary artifacts that go through a design process in order to arrive at. And again, the disciplines we're drawing upon primarily are mechanical, electrical, and software. And from a mechatronics point of view, oftentimes these devices are designed so that they can sense the world. And the world means the environment around it, but also maybe stimulus from a user. There'll be a little bit of decision making, and one of the outputs of decision making will be how to actuate something in order to convey information or to cause physical motion back in the world itself. So the notion of actuation. For now, we're not really going to worry too much about customers and the notion of product design and design process. We're going to focus really on how we use the fundamental engineering approaches from mechanical, electrical, and software engineering to create the devices and how to integrate those into a device. And this will take about 3 weeks. And once we're done with that, then we're going to open up the rest of the course to product design techniques that will inform the decisions we make about how the device should be built and what features it should have. So when we do device design, typically what you're going to do as part of the design process is you're going to break the overall required functionality of the system into sub-functions, sometimes called subsystems, with each subsystem responsible for a particular function. And then within those subsystems, you're sort of in a search for different approaches, different components that will achieve the sub-function required by the subsystem. And then across the system, you need to integrate all those together to make the entire device work. So what I want to do for the first part of the course is I want to walk through the different disciplines, mechanical, electrical, and software. And I want to sort of talk about what it means to have components with certain functions or behaviors in each of those areas. So we sort of build a toolbox of knowing what functions can be achieved by what different components in each of the disciplinary areas. And then when we do design, we have a lot of options in that toolbox that we can go and select from the different areas as options in order to make our final device. So when we talk about electrical functionality, apart from the components themselves, here this slide shows you some of the things that electrical components can do for you. So, for example, an input to your device can be a discrete input or an analog input. And so we can use sensors in order to understand what that input is and maybe convert it in different ways, filter it, use it for a user interface, things like this. Same thing with outputs. They're discrete and analog output kinds of signals that we can create in order to turn things on or off or to turn them on at a certain level. Again, we can also send information back to the user interface. There's various decision-making functions that we can perform in electronics. You see a few of them listed there, and so on and so forth. I'm not going to worry too much about going through the entire slide. It's here for your reference. Again, the point is that these are the sorts of things that electronic components can do for you from a functional perspective. From a mechanical perspective, here is a similar list. You can see things sort of in the structural realm in terms of environmentally protecting the parts and maintaining relative position of parts. You see things in the thermal realm in terms of managing heat transfer. There's the notion of mechanisms where we want to use things like gears and transmissions in order to cause motion between certain components, and oftentimes we do that with the use of mechanical advantage. And then there's control systems kinds of stuff from the dynamics and controls world. And with the devices we're designing, we might be interested in controlling things like speed or position or temperature or light level, things like that. And from the software world, here are some of the functions that we typically see. There's all sorts of data handling that we do in software to calibrate information, filter it, store it. There's flow and control. We do things over and over again in loops. We make decisions with conditionals. We can do decision making in a little more sophisticated manner with control laws. There are reactive and deliberative approaches to that. We'll talk about some of that in the class. And again, so on and so forth. You can see a list of different functions that software can do for you. So we have the three different areas: electronics, mechanics, and software, all of which are capable of doing a wide variety of functions that we can draw upon when it comes time to design our device. And it's worth pointing out that sometimes when we're looking for options to meet these functional requirements that we have in our subsystems, I think you're all familiar with the idea that there might be multiple options, and therefore you might do a trade-off analysis. But it's, I think, a good insight from the point of view of this class, an interdisciplinary class, to realize that sometimes those options actually span multiple disciplines. And a couple of really simple examples: if I want to filter out unwanted motion or an unwanted signal, I can do that with mechanical damping. I can sense the mechanical motion electronically and then use a circuit to filter out portions of the motion that I'm not interested in. Or I could relay that into a computer, and in software I could do digital signal processing to get rid of unwanted components. So there's an example of a mechanical, an electronic, and a software approach to filtering signals. I can do the same thing with setting control gains. There are things I can do from the mechanical, electrical, and software perspective to basically influence the gain of a control system. So we want to develop our understanding of functions across disciplines and populate our functional toolbox with different options in each discipline, but we also want to be aware that sometimes those functions will go across disciplines, and we might choose a mechanical versus an electrical versus a software option, depending upon what makes sense for our design. I also want to point out that on the engineering analysis side, when we do device design, it's important to realize it's just more than tinkering. When you do some more sophisticated things in this realm, you really will be using the analytic techniques that you learn in the different disciplines in order to improve upon the design of your device. And so some of the analysis functions that you might do in each of the different discipline areas are listed here. So I don't want us to forget that this kind of stuff underlies a lot of the detailed design that goes on. We're going to be playing fast and furious with some of the designs, and so we're not going to be doing really detailed engineering analysis in any one area. We'll do it here and there, but we won't be going in depth in this area. And I just want you to realize that this really is part of detailed design in the realm of devices, smart products, and interdisciplinary systems. And so finally, just to set up the flow of the course, I mentioned that the first few weeks here we're going to worry about sort of the light mechatronic kinds of topics. Let's review electronics, mechanics, software, learn a little bit about the components and the functions that they can provide for us. Then we'll turn that on its head and sort of say, well, from a design perspective, which of those components make sense for me and how do I integrate them together? That's the first 3 weeks or so. And then we're going to move out to more of the smart product kind of stuff. And now we're going to talk about products instead of devices. And along with that word change comes along this notion of the customer and what they need, and efficient ways of giving them what they need based on our choices on the engineering and the business side. So this is what we have in front of us for the course. These few slides, we're introducing the notion of devices, and now we're going to spend time going into electronics, mechanics, and software.